we are going over rule number 4 of 5. We're almost done, my goodness. With CO13, what happens when you have a negative power? Right? Now, you've actually come across negative powers before. Back in CO11, right, when we divided by the same base, if we had something like n to the third over n to the 7th, okay, what's the rule for CO11 with the exponents? What do?
Add them.
Not for dividing by the same base, no.
Subtract them.
Subtract them, okay? So some of you, when you're going through the homework, would take 3 minus 7, you'd subtract the powers, and what is 3 minus 7?
-4.
-4, right? And so you'd write n to the -4th. Of course, that's not your final answer. What I asked you to do, how I phrased this, was where are there more n's and how many more? Okay, we're going to come back to this in just a little bit. All right, this is kind of like your foreshadowing here, but we're going to make a kind of like a table or like a chart here. Write small, kind of write proportionally to how I am, so everything that I want to fit on here fits. But I said before that algebra is a lot of patterns, and we're going to describe negative powers by looking at patterns of things we already understand, things we've done. Okay? For example, if I give you 2 cubed, what is 2 cubed in expanded form?
2 times 2 times 2.
2 times 2 times 2. And what is the value of 2 cubed, or 2 times 2 times 2? Anybody? 8, right? 2 cubed, 2 times 2 times 2, that equals 8. Okay? Now, if I decrease our exponent by 1, if the next term I write is 2 squared, in expanded form, it's 2 times 2. And what's the value of 2 squared? Or 2 times 2? It is 4. Right? I decrease my exponent again to 2 to the first, which means I only have 1 2. And obviously our value of that is just going to be 2. Okay? So let's take a pause here and just describe for me what's going on here. What's the pattern that is developing as we decrease our exponent by 1, from 3 to 2 to 1? What's happening to our values? Landon.
They get divided by 2.
They're being cut in half, right? Because we have 1 fewer 2 there. Okay? So this actually falls in line with CO12. The next exponent I'm going to drop down to is what?
2.
I went 2 cubed, 2 squared, 2 to the first.
2 -1.
No.
2
2 to the 0 power, right? Decrease by 1. And what is 2 to the 0? It is 1. Does that follow the pattern that we've seen here? Right? Half of 2 is 1. So when negative powers kind of came into existence, mathematicians looked at this and they said, well, how can we explain this? How can we look at what we already know, even tying back to CO12 here, so that if I decrease my exponent again, if I now go 2 to the -1st power, what is my value of that going to be? Follow the pattern here.
-1. No, -2.
Dominic?
-0.5.
Just follow the pattern. Try again. Just 0.5 or half. Okay? Half of 8 is 4. Half of 4 is 2. Half of 2 is 1. Half of 1 is 1/2. First thing I want to point out here. Negative exponents do not make your base negative. Okay? Negative exponents do not make your base negative. It's not what they mean. I'll tell you what they mean in just a little bit. But if I decrease my exponent by 1 again, now I'm going to be at what?
0.25.
Well, okay, yeah. So if I decrease by 1 again, now I'm at 2 to the -2nd. What's half of a half?
A quarter.
A quarter. A fourth. Right? And then finally, if I do it one more time, coming full circle here, I started with 2 to the +3rd. I'm ending with 2 to the -3rd. What's half of a fourth? 1/8. I'll stick it over here. Okay? And so what I want you to notice here, we started with 2 to the positive third, which was 2 times 2 times 2, which is 8. We ended with 2 to the negative third, which ended up giving us 1 over 8. So in expanded form, it's like we had 1 over 2 times 2 times 2. Everything's the same, only where in the fraction it's flipped. When we had 2 to the positive third, our 2 times 2 times 2 and our 8 are in the numerator. 2 to the negative third, that 2 times 2 times 2 and that 8 are in the denominator. For 2 squared, we got positive 4. For 2 to the negative second, that's like taking 1 over 2 times 2. Kind of got off my lines here, which is 1 over 4. And then 2 to the first is just a 2. 2 to the negative first is just 1/2. So what a negative exponent means, really, is that your base is in the wrong part of the fraction. That's pretty much it. Hold on. Can I back a little bit? So what a negative exponent means is that your base is in the wrong part of the fraction. That's basically it. So looking back to what I started this with, that n cubed over n to the 7th, what I would ask when we did CO11, I would say, where are there more n's and how many more? And you'd say there are 4 more n's in the denominator, right? So the answer to this is actually 1 over n to the positive 4th. If you took 3 minus 7 to get negative 4, which is right, because that's what the rule is, subtract the powers, that negative 4 is where in the fraction right now? Is n to the negative 4th the way it's written here? Is it in the numerator of the fraction or the denominator? Numerator. There's no fraction bar, which means it's in the numerator, right? It's just in the wrong part. So by me phrasing it, where are there more n's and how many more? I didn't want you to subtract 3 minus 7 because we didn't talk about negative powers yet. Now that you know about negative powers, we can say 3 minus 7 equals n to the negative 4th, but then I have to move that to the denominator of the fraction because that's where I have more n's. That's the actual answer. This n to the negative 4th is in the wrong part. Now, be honest with me, who have I 100% confused at this point? That's okay. Okay? Who kind of thinks this is neat? Nope. Thanks. Okay. Let's look at some examples. This is the math behind it, but here's how we actually apply it. First, let's fill out the rule. This can go on a help sheet. It is a key point from up above. When you have a negative power, coefficients, like any other time, are not affected. Okay? Coefficients are unaffected by the power, which means they stay put. They don't go anywhere. Coefficients stay right where they're at. They are not in the wrong part of the fraction. I'll write this word a little bit neater. Stay put. There we go. Stay put. Okay. Exponents, because they're negative, the reason why they're negative is they're in the wrong part of the fraction, right? So exponents, what they do is they move to the other part of the fraction and they become positive. Because if you move it to the other part of the fraction, now it's where it should be. Now it's in the correct part of the fraction. It's happy again. So the exponent becomes positive. Okay? And then the base stays the same. Notice I didn't say it stays put. The base stays the same. It doesn't change, doesn't become negative, okay? But moves with the power. but it does not become negative. That's the biggest mistake that folks probably make, is they make their answer negative when it shouldn't be. Okay? So let's look at the first one here. 7 n to the negative third. What is the base of that negative 3? N, which means this base is in the wrong part of the fraction. Right? So we'll remove it.
In front.
Not in front.
Behind.
Nope.
Below.
Below. Right? Remember, this is technically written 7n to the negative third over 1. We just don't write the over 1 because we don't have to. But right now it's in the numerator, which there are only two parts of fraction. There's the numerator and the denominator. So if it's wrong in the numerator, if it's negative there, we're going to move it down. The 7 stays put. It's a coefficient. Nothing happens. But then in the denominator, it becomes n to the positive third. And it changes from negative to positive because you moved it. It was in the wrong part of the fraction. You moved it to the correct part of the fraction. Don't make this more complicated than it needs to be. I'm not saying that it's easy, but don't make it more complicated than it needs to be. Right? Don't read too deep into what does a negative power mean? Basically, it's in the wrong part of the fraction. That's it. So 12x to the negative 9th times y, which base is in the wrong part of the fraction?
X. No, Y. No, it's X.
It's x, right? The y's got a power of a negative or a positive 1. It's not written, but it's there. That negative 9 only applies to the x, which means only the x gets moved. So our 12 and our y are still in the numerator. X to the positive 9th is now in the denominator. It might be easier to visualize this with the next one because it's already a fraction. But that n to the negative 5th, that negative exponent, even if it starts in the denominator, still means it's in the wrong part, right? So n to the negative 5th, that's what gets moved. Where does it go?
Up top.
Up top, the other part, right? Does the 2 change at all?
No.
The 3 change at all? No. The numerator just gains an n to the positive 5th because we moved it, and the 3 stays down in the denominator. Okay. Then that last one, it's got 2 negative powers there, which means we have to move 2 things. T to the negative 3rd, it's in the wrong part. It's in the top, well, we'll move it down. C to the negative 10th, it's in the wrong part, we'll move that up. It is flip-flop. Right? C to the positive 10th is now in the numerator. Remember, the base goes with it. The base doesn't change. It's still C, but it goes with it. And then T to the positive 3rd now in the denominator. So those who said they were confused before, is it a little bit better? Have I impressed anybody else? Yeah? Yeah? Oh, okay, good. All right, okay. Any questions from this? Scarlett? No? Okay. All right, let's look at the bottom row. 1 over h to the negative 1st. Now, usually when we have a power of 1, we don't have to write it. You know, like the y to the 1st up above there. But if the power is negative, then we do have to write it because that tells us it's in the wrong part of the fraction, right? So when you see a negative 1st power, we have to write it because that means we have to move it. And if it's in the denominators to start, that means we move it up top, okay? And so we have our 1. We're gaining an h to the 1st, positive 1st now, right? And if we move that out of the denominator, what's left is a 1. So we have 1 h to the 1st over 1. What's a much simpler way to write that? Landon. You said h? I don't use this too often. Yeah, just h, right? All those other ones are unnecessary. We have a coefficient of 1, unnecessary to write. A power of positive 1, unnecessary to write. A denominator of 1, also unnecessary. All three of those are part of that hidden math poster in the back there. The blue, the orange, and the yellow square. All describe a denominator of 1, a coefficient of 1, a power of 1 as being unnecessary to write. So just H. Okay. Next one. What are we moving here? What are we moving here? Nolan.
The A.
We're moving the A to the negative fifth.
And the C.
And the C to the negative first. We don't move the 18 because that's a coefficient. And we don't move the B because what's the exponent on the B?
1.
Just a 1, positive 1, right? So 18B are going to stay right where they're at. They're in the numerator. They're going to stay up there. And our denominator will now have A to the positive fifth and C. If you want to write to the positive first, you can. You don't have to, okay? But it becomes positive. Do the next two on your own. Take like 2 minutes. Check your answer with a partner. Identify what needs to be moved. Move it. And then what's your final expression there?
All right.
No.
Okay.
Another minute to go here.
No.
You didn't finish.
No,
you're trying to talk
he's not copying.
He's not
I'm
copying.
teaching
Every
him.
joke. Okay.
I know how to do this. You're talking like a
All right, come on back here. Take a look. You can stay where you're seated. Whatever. So in that first one, what gets moved? The negative powers, the B and the N. The B ends up going down to the denominator. The N ends up going up top, right? They kind of flip-flop. Our A squared stays where it's at. The power is positive, doesn't go anywhere. Our N to the 7th joins it, right? It's negative in the denominator. It's in the wrong place. It goes up the top. Now it's happy, right? And then in our denominator, we have our Y to the 11th. That stays put. It's positive. And then B to the positive 9th joins it, okay? Who was successful? Who's got questions? Yes. Yes.
Are you preppy?
Am I preppy? I need a definition of that word. I think the definition of the word has changed over the last 39 years, so I don't know.
I bet Penelope can give you an accurate definition.
Last one. N to the negative second is what gets moved. The 4 stays where it's at. The Y squared stays where it's at. N to the positive second in the denominator because it moves to the other part. Okay. Your homework for tomorrow is the next page, and you'll notice there are 16 questions on them. Not all of them have negative powers. Okay, folks. The next page is a review of all the rules we've covered so far. Today was rule number 4. The top row, you see a whole bunch of multiplication symbols. That's because it reviews CO10. The second row are all fractions. That's CO11. The third row has a bunch of 0 powers in it. That's CO12. And then finally, CO13, negative powers. That's the bottom row. So be using your binder, flipping back. Okay? Flipping back, read the rules. And it is a review of things we've done previously. You've learned 4 rules now. This reviews all of them. This is going to be due tomorrow. Would anyone like me to go through one up on the board? I see some faces that are like cries for help. What? else gets me choked up. Tristan.
The bottom one, the first one on the bottom.
This one with all the letters?
Yeah.
Yeah. So this one being a negative power one, like we just talked about, you're looking for the bases that need to move. I see a squared, positive 2, that one's fine. B to the negative 5th, that'll have to move. C to the negative 9th, that'll need to move. D cubed is good. E to the negative 15th, gonna move that. F cubed, that stays. G to the negative 6, move that one. H to the negative 8, move that one. That's all there is. Okay? Anything with a negative power is simply in the wrong part of the fraction. So you move it. Right? So you move it. We are out of time, and so this is gonna be homework for tomorrow. That is how you math. Do the like, do the subscribe.